Here we are on the work, 633, one equation or two. Elsie took all her cans and bottles from home to the recycling center. The number of cans was one more than 4 times the number of bottles. I see that right now, and I see that basically I can write in a little equation. So I'm going to write it right now. I'm going to write in a different color. The number of cans, well, cans we're always going to call C. So it equaled 1 more than 4 times the number of bottles. So what I'm going to do is 4B plus 1. Okay, because the cans are equal to 1 more than 4 times the number of bottles. Tricky, but essential. So we have a little equation right here. Next, she earned 12 cents for each bottle. Okay, so for every bottle, she earned 12 cents and 10 cents for each can, and she ended up in $2.18 in all. Okay, so what I see there is she gets 12 cents for each bottle. So she gets 12. Oh, let me get back to my better font color. She's going to get 12 cents. So 0.12 times the number of bottles. Plus she gets 10 cents, or 0.10 times the number of cans. And we know that all of that together is going to be equal to $2.18. So 0.12 times the number of bottles plus 0.10 times the number of cans is equal to $2.18. How many bottles did she recycle? Okay. So Solomon wants to solve this problem using just one variable. So we're going to define a variable using a let statement, then write the equation so that Solomon could solve the problem. Okay, so what we know is that cans are related to bottles. So if we say let B equal the number of bottles, we can write this. Now we need to write an equation that only uses that. So what we know is that C equals 4B plus 1. So what I'm going to do is I'm going to take this equation, but instead of writing C, I'm going to write 4B plus 1. So this equation works with the 4B plus 1 in its place. So I will substitute, and I'll go to the pink again because it's easier to see. 0.12B plus 0.10, but instead of using C, I'm going to use what I know for B, which is 4B plus 1. And that's going to be equal to 2.18. All right, because 12 cents per bottle plus 10 cents per can is equal to $2.18. Now we need to solve Solomon's equation and answer the question in the problem using a complete sentence. So I'm going to take Solomon's equation, which is a great equation because it puts the entire thing as one variable instead of two. And here will be the steps to solve it. First thing I'm going to do is I'm going to distribute this 0.10. And what that's going to get me is 0.12b plus 0.10 times 4 is 0.40b plus 0.10 times 1 is 0.10 is equal to 2.18. So now that I've distributed, I can combine like terms. I can combine the two b terms. So combine like terms. And that's going to get me 0.12b plus 0.40b is 0.52b plus 0.10, which equals 2.18. So now I've got it all in terms of b. So now I just got to get the b alone to figure out basically how many bottles. So what we're going to do is we're going to subtract this 0.10 from both sides, right? Because we're trying to isolate the variable. And what we get is 0.52b is equal to 2.08. And then to get b alone, we'll divide by 0.52. So both sides. And that gets us b is equal to 4. Check the math, it's true. 2.08 divided by 0.52 is 4. Okay, so we need to write a sentence. Solomon told us that B equals 4, and as we said before, let B equal the number of bottles, so the number of bottles is equal to 4. Good job, Solomon. Very smart. Okay, now we're going to look at C. C says Marcus wants to solve the problem using two variables. Define your variables using a let statement, then write two equations that Marcus could use to solve the problem. Okay, this is not as hard as it may seem at first. Let B equal number of bottles. Let C equal number of cans. Okay, simple as that. Now we've already actually written these equations earlier on. We were able to say that C equals 4B plus 1, again because the number of cans was 1 more than 4 times the number of bottles. So 4 times B plus 1 equals C. So I'm just going to copy and paste this because that's one of Marcus's two equations. The other equation is that 12 cents per bottle plus 10 cents per can equals $2.18. So that's our second equation. Marcus has two equations. Okay, do Solomon's equation and Marcus's equation represent the same problem? Why or why not? We look at Solomon's equation here. It's basically this equation, but it contains a substitution. Instead of the C that we see here in Marcus's second equation, we see 4B plus 1, which is the substitution of the value of C. So they do represent the same equation, same problem. They do represent the same problem. Solomon has simply substituted 4B plus 1 for C in Marcus's second equation. Okay, so now we're going to show that our solution for part B makes sense for both equations in part C. So what we'll do is we'll just copy these down here. This isn't F, this is just copying. And we figured out that B was equal to 4. So what I'm going to do here is I'm going to substitute in 4 for B. Okay, so C equals 4 times 4 plus 1. So now we can continue this. 4 times 4 is 16. 16 plus 1 is 17. Therefore, C equals 17. Now that we've got that, I can sub in 4 for B and 17 for C and see if it works. So B was equal to 4, so I rewrite it as B is 4. C was equal to 17, so I rewrite it as C equals 17. And I test to see if it works. 0.12 times 4 is 0.48 plus 0.10 times 17 is 1.70 is equal to 2.18, and this is true. It's true for both variables. So Marcus's way works, Solomon's way works, they're both successful.